Okay, now you can pull out your geometry. Just make sure it is 2D. Okay, file, open your Solidworks file. Okay, now you can close the window. And pull out ICEM FD. Okay. Now the first step is to name your inlet. The procedure is similar to my meshing strategy. Uncheck inlet and now do for your outlet. Now shell 3. Just going to fast forward for you. Shell 2. Shell 1. And shell 0 near the trailing edge. Okay, next will be to name your Y plus. Zoom into your blowing region. And then uncheck Y plus. And create normal lines. It's a small edge over there. So let's near the offset. You can see the white line. Okay, and then select the remaining normal lines. Okay, hide your normal lines. And then we can start selecting the upper surface of our airfoil. I just use the normal lines to locate my leading edge. Okay, and hide my airfoil upper. And now for airfoil lower. Just gonna hide the points. Notice that I exclude the blowing region. You'll need to do some adjustment here. Okay, under the geometry tab, the 3 dots here, we are going to select this one here to introduce 100 points on this segment. We're going to divide the segment afterwards. Points method and points, number of points is 100. Now you can select the edge and name it as blowing points. Okay. I'm just going to name Y plus points to exclude this point here. Okay. Hide them. And now I'm going to select this one, the second one, to modify this curve here. First, I select the whole segment, and then I continuously select each and every point on the curve. Just going to fast forward for you. Okay. Then I'm going to name the host and the wall on this segment. Will be being alternated. First the hole, and then wall, hole, wall, hole, wall, something like this. For blowing holes. Now just do for the wall, can just select this one to exclude any points in my selection, and then I'm just going to use a box select to select all the remaining edges. Okay. It's quite difficult to see here, so I'm just going to change the color of airfoil blowing holes to yellow. So now you can see that it is alternatingly holes and wall. Next will be to name our guide curves. GC in short. Okay, now I'm going to show my inlet and outlet, and then we are going to start meshing. Create block here under blocking. The part will be named as fluid. Type will be 2D planar. Okay, blocking. Associate edge to curve. Select the 3 edges, and then I want to select my curves for the inlet. Same thing for my outlet. Next step will be to create an O-grid, the second one over here. So the second one here. Select block, the first one. Okay, and then select edge, third one, and just select my outlet. Yeah, I'm just going to turn on the point so that I can split the block here near the trailing edge. Okay. Next step will be to merge the third one here with 3 points. I selected the edge behind my trailing edge as well as this block here. Now just splitting the block. And then I'm going to merge this block here, the 2 triangles, using this step. Add the block, the first one here. So I just chose something 1 and 4. Okay, then I'm going to name it solid. Select this one over here to select a block. And then I'm going to hide solid. So this triangle over here is actually going to follow the contour of your airfoil. This will be your leading edge, this will be your trailing edge, and this will be this point will be the first guide curve on the top surface. We're going to add 3 more over here on both sides. Since this is the edge for the first guide curve, so I know that it will be here. It should be associated to this vertex. You can zoom in and then turn on normal lines just to locate my leading edge. might as well just turn on everything so it's clearer for you to see. Select that vertex to our leading edge. Okay. And that one to the lower surface. Same thing for the top. Okay. Now just going to associate to the trailing edge. And split block to introduce this, the limit for the weight relief. Associate the vertex to the points to nail it down. Okay. Before splitting, I will associate the edge to the upper surface. Just gonna hide the lower surface. Okay. It's like 1, 2, and then I'm going to hide the edges. Okay, and then just box select. Okay. Okay, so we're going to split the F1 into 3. First segment, second segment, third segment, according to the guide curves. Okay, first one, second, and third. Okay. Just associate the vertex to the corresponding points. It should be on the F4, so it's the innermost point. This one is shell 1, shell 2, and shell 3. Okay, it's easy to see where should we associate those vertices. You know, I think I can hide guide curve. Okay. Yeah, this is just a fancy way of isolating it just for you to see better. Don't need to do this, but if you want to, you can right click on blocking, and then you can what's the term? I can't recall it. But then this tab will come out so that you can isolate which part of the block do you wish to see and which do you want to hide. This way I can easily box select and associate to this edge. This edge will be limited to this one. One, two. Okay. I don't really need to use this actually, but just to make things clear. Next step is to split and create shell 3. I'm just going to reset. Okay. Just associate those vertices, the points. We are going to repeat this same procedure for shell 2 and shell 1. You can just approximate so that when you are playing around with splitting, so that this line here is very close to these points. It's just good practice. So it's easier for you to associate. Now for shell 1, okay. Now we can go to the outlet and see. This is the reason why it is good practice for us to approximate the shell to be close to the points near the trailing edge, so that this will be close to. So it's easier for us to locate. Okay, we are done with that. You come back to the airfoil. Yeah, it's in this control. You can play with O3. This is to control number of shell. IJK is just up, down, right, left. Okay, nothing fancy over here. I just split the airfoil according to each point, so that I can better define the airfoil. But most importantly is because I want to maintain the cells to be almost always normal to the airfoil. So this will be guiding the cells as it grows outwards. Okay, just splitting and associating, nothing much. It's tedious, but it helps. Okay, we are done. Okay, now again, play with the index control, because I want to isolate only the shell so that I can easily associate all the edges to my curves. Okay, I'm going to turn on shell 3. So before that, I think I'm going to hide outlet. Okay, call out shell 3. Oops, not vertex, it should be edge. Okay, so she edge to curve. Box select everything. Box select everything again. We are done. Okay, we can play with O3 to reduce number of shell. Increase the minimum value. And then repeat the same procedure. Okay, last one. Increase minimum again. Box select, box select. Okay, now for shell 0. Just directly associating them. to associate guide curves. 1, 2, 3, 1, 2, 3. Do the same thing throughout the airfoil. Or also for the normal lines. This because it is curved here. This is not a straight line, unlike this one. Okay, now back to the guide curves. 1, 2, 3. Oops, 3. Okay, 1, 2, 3. Same thing. Okay. Can hide my guide curves. Almost everything is in green now, meaning that they are being associated. Now it's time to do our holes and walls. And turn on the blowing points actually. Okay. Turn on my points. And turn off jump 1. Jump 1 is just the yellow points. Okay. Okay, split block. Right. There's a lot of repetitions in this example. Just now, I got an error from ICEM, but I can just continue saying, just click OK. But right after, please save your file. And then if something got stuck or something like this, just use your task manager and end task for ICM, and then just restart again from where you last saved. That should work. Because a lot of splitting and associating somehow is prone to having errors. Okay, we are done with splitting. Then we need to associate the vertex to the points. Okay, fast forward, not to waste any time. Okay. One last vertex. Okay. Next step, once we have the segments divided, it should associate each group of holes to the airfoil blowing hole, and each group of walls to airfoil blowing walls. Okay, now the first step would be do for the holes. You can hide edges, hide points, and just show airfoil blowing holes. Select curves and box select. Okay. I'm going to do the same thing for airfoil blowing walls. First is to select okay, and hide the edges, hide points, and then turn on airfoil blowing walls, select curve, and then just box select. Okay, we are pretty much done. Now for the Y plus, and select corner, So this is our blue region. And turn on Y plus points and Y plus. Okay, then split. Okay, reset, select corners, play around with O3, turn on points, and associate vertex to point. Then at the offset, vertex to point, as well as associating the edge to the curve. Okay. Reset. Actually, that's the only difference with my previous meshing video. Now we're just going to assign number of nodes to each segment. Oops. First, I think we should go to CFT Online and see what is our Y plus value, 2.1 to 5. Okay, it's a bad idea to start with that edge. I should start here, but anyways, you can see the difference. At least you can learn. It is always geometric 2 for boundary layer. At 31, but the problem arises that this small segment has 31 nodes, which is wrong. This is where I noticed that there are 30 nodes, this small segment. Should be at least 2. So I adjusted this segment here. Okay, now it's 3. Now this one can be 2. Okay, right. 2 meaning this is the first node, this is the second node. Okay. Now first I'm going to match the spacing from this length to this length. That is actually just Y plus 1. So this is the value, 2.03. It's not perfect, but it's close. Use geometric 2. And then hit 30. Okay, now my growth ratio is 1.127. That's okay. Then I'm going to copy the spacing 2 and use that to start my normal line here. See, I applied spacing 2 here. Just going to double check. Okay. Now in the clockwise direction, Spacing is 0006. We make it 22 nodes, then it is slightly growing. We want it to be constant, so I made it 23. Spacing is now 00058, which is close, so it should be okay. So I applied this number of nodes 23 from this segment all the way to this segment here because the spacing is equal, right? Okay, one last one, 23. Okay. 0005. Now I adjusted the number of nodes from the leading edge first as I go towards the back downstream. Okay, this one at 7 nodes, I get 0004, 0005. Okay, that should be okay. With 8 nodes, 0005. Okay. Five nodes, 4 nodes, 5. This one is 5. Okay, we are done. I just mesh the edges. You don't have to, but you can if you want to. Okay, now after the blowing offset, spacing is the same, 0006 around this value, 0059 with 21 nodes. Okay, can get away with that. We'll just apply it to the remaining segments, 21, 21, 21. Okay, now I'm going to match the edge from the trailing edge to the wake. I'm going with geometric 1 with 50 nodes. Okay, and then match the spacing again. Geometric 1 with another 50 nodes. Should be okay. Now as I grow away, the mesh is growing away from the airfoil. It's always geometric 2. Just increase your number of nodes until your ratio 2 is okay. Usually I go with 1.05 until 1.0, 1.1. 2, go with 50. Pressure 2 is 1.09, so it's okay. Turn off the edges and pre-match. Okay, there we go. The mesh looks okay, looks nice. Let's just zoom into the boundary layer. On guide curve so that I can locate my blowing region. Okay, this is my guide curve. So this should be the blowing region. It is uniform, okay. This is the Y plus reference reference length. Okay, the challenge looks okay. You can just check the quality first before converting. The determinant battery value is 0.89, so it's very good. Resistance skewness minimum is at 0.6. It's not the best, but I'm going to show you that it doesn't really matter because it's quite far away from the airfoil. Okay. So at 0.8, only this area is being affected. So I think it should be okay. Replace. Okay, output mesh, our solver is ANSYS FLUENT. The boundary condition, let's make it wall for now for alpha blowing pose. Okay, this is also wall. For lower, a wall. For upper, a wall. Everything besides inlet and outlet should be interior, meaning it doesn't disturb the flow. It's just part of the mesh. Outlet, pressure outlet. Show 0, interior. Shell 1, interior. Shell 3. And finally, Y plus. Interior. Okay. Accept. Save the current project. Don't forget to change it to 2D. Done. And I'll see you in part 3.